ask you two different questions today, and the main thing that I'm looking for is what's the difference between these two questions. So if I were to ask you which classmates are wearing denim, so like a blue jean type material, no matter what color, and have a colored shirt on, so a shirt with some kind of color, versus the question, which classmates are wearing denim or have a colored shirt on? What's really the difference between those two questions?
One is both and one is either or.
All right, one is both and one is either or, okay? Which one's both? They've got to have both and, okay? And would refer to, they would have to have both things, right? They'd have to be wearing denim, and they'd also have to have on a colored shirt, all right? The second one, the clue word in that one is or, and that means either option, we would count them, okay? Come on. It wants me to, again, I said it wants me to talk ugly today. They're going to present in here tomorrow, and I hope all my stuff acts like this so that they know it's jacked up. Because I've told them, and nobody's listening to me. Okay. There it is. All right, so it means either one, or means either one. Okay? So that's what that is. Okay? Well, today we're going to talk about a little different type of probability, and I'm going to show you two ways to organize data, okay, for those probabilities. And we're going to do it by taking a little data about ourselves. So we're going to talk about two-way tables and Venn diagrams. Anybody ever used a Venn diagram? Usually you do those in English. Do you know what those are? They're the circles, right? Where the circles and they overlap. We can use those in math as well. My daughter's so goofy. And then we're going to talk about calculating probabilities using those two models. Okay? And so just a little difference to that. Okay. So today we're going to collect some data. It says, can you taco tongue and evil eyebrow? Now, let me explain what those things are for just a second. Taco tongue means that you can roll your tongue. Okay, it actually is a genetic trait, so not everybody can do it. Okay, so it's okay if you can't. The other thing is the evil eyebrow, where you can raise one eyebrow higher than the other. I can't do that. I just look like this. I can't do it. Okay? Yeah, Addison's nailing the evil eyebrow back there. Yeah, okay? So think for a second. All right? Check yourself. Which one can you do? Which one can you not do? Okay? And if you can't do either, that's okay too. All right? So, because my mom, she thinks she can roll her tongue, but she can't. And we just laugh at her because she goes, look, I'm doing it. And her tongue's just sticking out. We're like, no, you're not. Yes, I am. No, you're not. Okay. Anybody know somebody that can fold it like twice? I knew there'd be somebody in here that could. I can't do that either. Okay. Anyway. Yeah, some people can. I was like, no thanks. All right. So I need to know which category you fit in. Okay. So I am a yes to the taco tongue, but a no to the evil eyebrow. So this is where I fall, is in that category. Okay. And you don't have to copy down the tick marks because I'm going to tally them, and we'll just write down the tallies. Okay. All right. So let me talk to everybody. All right. Quintez, can you do either one of those? Which ones? Both. He's a both. So he's going to go in that first corner. All right. What about it, Eddie? You can only do one. Which one? The first one, the taco tongue. So yes and a no. You're like me. All right. What about it? You can't do either? That's okay. We need everybody. We need people that can't do either. All right. What about it, Josue? Yeah, you got that one? Can you do the eyebrow?
He can do his eyebrows.
Let me see you do your eyebrow. Can you do your eyebrow? Can you lift one eyebrow? No, not shutting your eye.
Like one? That one?
Yeah, just one at one time. No. Okay. So you're there. Okay.
You know I can.
Oh, gosh. And you can do them both and switch them. God bless it. Multi-talented, not I. All right. What about Devin? You can do just the tongue. All right. Most of us fall in that category.
Just the eyebrow.
Just the eyebrow. Okay. That's the first one in that box. Okay. What about it, Dani? Can you do either one? You can only do the eyebrow? Okay. So I'm going to put you right there. What about it, Chanel? Oh, she can do both. Yes. Just the tongue. Okay. All right. Ah, my multi-talented people up in here. Okay. Ooh. Okay. I have to tell y'all are my first group to have that many with both. What about Jonathan? You do those? Just the tongue. Okay. See over here with me. All right. All right, I got y'all. What about it, Faden?
Both.
Oh, okay.
Both.
God bless it.
Both.
Woo!
Not the evil eyebrow.
Oh, sorry.
Just the eyebrow. Okay.
Give me some eyebrows.
So I'll put you right there. All right, Hannah. Neither one? It's okay. Cam, you do either? Okay. All right, so let me count my tick marks. I'm going to erase these, and then we'll just put the overall numbers in there, okay? All right, so for that first section, I had 1, 2, 3, 4, 5, 6, 7. Oh, I can't count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, 10. All right, so let me erase that, and I'm just going to put 10 in there as a number so I don't have to worry about it. Okay, so I'm going to put 10. And then and the one next to it, 1, 2, 3, 4, 5, 6, 7. So erase that. Just put 7. A little easier to read. And then 3 and 3. Okay. Okay, so I've got 3 and 3. Okay. Now, it asked me to fill in the totals. We don't really have a box for those, but they go underneath. So the total number of people who can definitely do the eyebrow is 13, if I go down. And the total number of people who cannot do the eyebrow is 10. Okay. And then if we go across, the total number of people who can do the taco tongue are 17. And the total people that can't is 6. Now, here's how you know if your table's correct. When I add the totals up and down and sideways, it should be the same number, okay? So 13 plus 10 is how much? And then how much is 17 plus 6? 23, so we did it right, okay? So this is my total people, okay? What we just used is what's called a two-way table, okay? It's called a two-way table. Notice we've got some characteristics. One column is yes, one column is no. On the other side, we have a yes characteristic and a no characteristic. And so a lot of times what you'll see them refer to these as, remember we talked last week, like if this was event A, if it's not A, we called it a complement, and it would have that little C next to it, okay? So a yes and a no. So you're going to start to see some of that notation. Yes being, hey, I can do this thing. And then no being, hey, I can't, with that little C up there at the top. That tells me no, all right? The other characteristic, they would call it B. So yes, I could do that characteristic. And then no, it would be B with that subscriptive C for the complement, all right, as a no. Okay, so those C's mean complement, which just mean no, okay? So just so if you were to see that. Okay. Now, what's great is when I do this two-way table, it gives me 4 numbers, 1, 2, 3, and 4, okay? I calculated the totals just to make sure that I did it correctly, all right? That I had the right number of people represented, and they both worked out to be 23, okay? So when we do a Venn diagram, which is what this is, all right, we're going to take those 4 numbers, the 10, the 7, the 3, the 3, and we're going to put them in this box, all right, and in the circles. So we've got a spot right here that says, hey, yes, I can do the taco tongue. Then I've got one that says, hey, yes, I can do the evil eyebrow. What do you think this one in the middle represents? Both, okay? So let's start with our both. How many people could do both? So yes and yes. 10, okay? So I'm going to put 10 inside of there, okay? So yes and yes is going to go in there. Now let's take the people who were just yes, but were no on the eyebrow. How many people was that? 7. Okay. And then I want people that were just yes on the eyebrow, but no to the tongue. There were 3 of those. And so now I've used the 7, the 10, and the 3. What's the only other number that I've not used? That other 3. And that's for no and no. That's why they're outside the circles. Okay. So both is always going to go in the middle. Neither is going to go outside. Okay? And that's what we refer to as a Venn diagram. Okay, so that's our Venn diagram. So both is always going to go where the circles overlap, and then neither is going to go outside the circles, right? So now we want to find some probabilities, okay? And this is where we just have to be a little bit more careful, all right? We can use the table, we can use the Venn diagram, it doesn't really matter, okay? So it says first that we want to suppose that we randomly choose a student from class, all right? And we want the probability that, yes, they can do the taco tongue, okay? So when I think about that, how many total people can do the taco tongue? Where would I go in the table to look at it? Okay, so let's see. These people are yes to the taco tongue. Are these people yes to the taco tongue? Are they in the same line? They are, so that's my yeses. So that would be 17. Okay, so it would be that top line. It would be 17. Okay. And then how many total people did we have? 23. So I'd have 17 out of 23, and let's just leave it as a fraction. We could divide it to get the decimal, but let's just leave it as a fraction. Okay. So then if we want to do the people that were no to the taco tongue, right, let's go down. Let's look at all of the no people. So no taco tongue is right here. So it's everybody that goes across. How many is that? 6, all right, out of our 23, right? And then we have yes to the evil eyebrow. So we're going to switch, all right, which part of the table we're looking at. So this time I want all the people that are yes to the evil eyebrow, okay? So yes to the evil eyebrow. Okay. We're going to go up and down right there, okay? So yes to the evil eyebrow. And how many total people is that? 13. And then we switch, and the last one we do is no to the evil eyebrow, which would be that column. So how many people was that? 10 out of 23, okay? Now, let's think for just a second how we could have gotten those numbers. Let's say we didn't have the chart, but we just had the Venn diagram, okay? So this is where we have to be careful. If we think about the people that are yes to the taco tongue, well, that's easy. It's these 7 right here. But can these 10 people in the middle also do it? They can. So we'd have to add them together. 7 and 10 would give me 17. Okay? Then if we wanted the people that were yes to the evil eyebrow, we would have to take the 3 in the outer part of the circle plus the 10 that could do both, because they could do it as well. All right, so 3 and 10 gives me 13. Now, this is where it gets tricky. People that cannot do the taco tongue at all right? We couldn't include any of these people who are in this yes circle. We'd have to include everybody else. So 3 and 3 would give me 6. Okay, so I think it's a little harder from the Venn diagram than it is from the chart. All right, because I can kind of highlight and see, but I have to really do some thinking about what the Venn diagram means. And then no to the evil eyebrow. I could not take any of these that are in the yes eyebrow circle, so I'd have to take these 7 that are out here and the 3 that are neither. So 7 and 3 gave me 10. Okay, so that one's a little bit tougher when I look at it from the Venn diagram. All right, but we'll have to do it both ways. All right, it's kind of what we have to do. Now, let's get a little bit more into it, okay? So this time, I want the people that are yes to the taco tongue and yes to the evil eyebrow, okay? What do you think about that one? Yes to the taco tongue and yes to the evil eyebrow. What would they have to be able to do to be in that category? They have to be both. They have to be yes and yes. Okay? So which group is yes and yes? Just those 10 right there. Okay? Those 10 right there are yes and yes. So 10 out of 23. Okay? Then it says, okay, what's the probability that they're yes to the eyebrow and no to the tongue? All right? That's very specific. Okay? They've got to meet both requirements for and. So yes to the taco tongue, no to the eyebrow, 7 out of 23. So to me, that one's pretty simple. It comes straight off of the chart. Okay. Then we have, let's see. They asked me the same question twice. Oh, they asked me yes to the tongue and no to the evil. Oh, wait a minute. I think I put that in the wrong spot, didn't I? Yes to the evil eyebrow. And no, yeah, this one should be 3. I read the wrong one. Sorry. This one, yes to the tongue, no to the eyebrow, is 7 out of 23. Sorry, I read my chart wrong. And then no and no, that would be that last 3 that we hadn't talked about. Okay. So those are specific. When it's and, we're looking for they got to have both characteristics, okay? So if they don't have both, we can't use them. Okay. So now it wants me to take it just a little bit farther, okay? And we've already done this first one. Yes to the evil eyebrow, we said to start with, was 13 out of 23. No to the evil eyebrow was 10 out of 23. Does it make sense, okay, that if it's the yes and the no for the same thing, that it adds up to my 23? It should, okay? 13 and 10, it should add up to my 23, okay? Now, we talked the other day in our probability, if I was going to do an or statement, okay, that as long as they were mutually exclusive, all right, which means they don't share any outcomes, we can just add their probabilities together. And so if we look at this one, yes to evil eyebrow or no, can I be yes and no at the same time? Not really, right? So they're independent of each other. So then I would just add these two together, all right? 13 over 23 plus 10 over 23. It should give me everybody. 23 out of 23. Yes and no to one category should give me everybody. Okay, everybody should fall in those categories. Right? So now, let's look at this next one. And this is the new thing. Okay, so that last one was what we did last week. They were mutually exclusive. They really don't impact each other. We just add them together, go about our business. They're the same category. A yes and a no should add up to my total. Okay? But look at this next one. The next one says, all right, what is the yes to the taco tongue? So how many people did we say up here were yes to the taco tongue? 6, right? Out of 23. And then how many were yes to the evil eyebrow? Wait a minute. Did I write that down wrong? No, I didn't. Yes, I did. Hold on. All right, let me erase that bad boy. Hold on. Make it bigger so I can get rid of it quicker. All right, go back up here to the top because we already did all these probabilities. So yes to the taco tongue we said was 17. All right, so 17 out of 23. And then yes to the evil eyebrow was 13. Okay, so yes, and then yes to one, yes to the other. Now this time it asked me to do an or statement again. All right, and this is where we got to understand what we know about probability. Okay, probability is always going to fall between 0 and 1, which means if I add two fractions together, it should never be greater than 1. Okay, so because it says or to these two categories, if all I did was add the numerators together, what's 17 and 13? That's 30, right? But how much is my total? It's 23. So this is not possible. This is what we call events that are not mutually exclusive. They're going to share some people. Okay? So they share outcomes. Right? They share outcomes. And so in order to get this probability, okay, we can't let it be more than 1. So we're going to take those two probabilities that we found, the individual ones, but it's too much. So we've got to subtract out the number of people that they share because we don't want to count anybody twice, okay? So we're going to subtract out the people they share. Okay, so if I'm talking about the people that are yes to the taco tongue And then the people that are yes to the evil eyebrow, who would be the people that they shared? The both, okay? It would be the both, which are these 10 people right here, okay? So we're going to come up here, and we're going to share out the people they shared. Subtract out the people they shared, which is both. So I'm going to subtract out 10, okay? So when we do that, 17 and 13, we already said was 30. I take away 10. That leaves me with how many? 20 out of my 23, and that's good. That's less than 1, so we're okay. Okay, so we're okay. If I just done the first 2, it couldn't possibly be right because I got 30 over 23. We can't have a top-heavy fraction. Okay, so we got to subtract out some things. They share some people. Okay, nobody gets counted twice in probability. It's not fair. Okay, so this is what we refer to as the general addition formula. Okay, that's what this is referred to, is the general addition formula. I want to show you the crazy probability notation that you're going to see on a formula sheet, and it looks something like this. Probability of A or B, okay, probability of the first thing plus probability of the second thing minus the probability of both, okay? And what I just remember, ask people to remember that this is the both. We subtract out the both, okay? So whatever that first characteristic is, we're going to get its total probability. Whatever that second characteristic is, we're going to get its total probability. And then we're going to subtract out all the things that are in both, okay? So minus the both, and that's how it works, okay? So what we're going to focus on today is creating a two-way table, getting probabilities from a two-way table. Can we take a two-way table and throw it into a Venn diagram, all right, and vice versa? And then can we do some of this probability? When do we know when to subtract? Okay, so that's the kind of thing we're going to look at today, all right? So flip that over and let's just kind of organize this really quick. Okay. And I like to show you this general table for a two-way table. It's actually what I put on your formula sheet for your quiz on Friday. Okay, so you have this to reference. So when we talk about a two-way table, okay, I got 4 boxes. I have event A and its complement, which just means no, so a yes and a no for one thing. I have a yes and a no for a second characteristic, okay? It's going to give me 4 different numbers, okay? So I have the people that are both, the people that are one, the people that are the other one, and the people that are neither, okay? So the first box is both, the last box is neither. Okay, so both and neither, okay? When we transfer that to a Venn diagram, okay, we're going to always use those same 4 numbers, right? The both number is going to go in the middle. The neither number is going to go out by itself, so not in the circles. Okay, so those numbers are going to go in those places every time. Okay. And then the people that can do the first event, okay, but can't do the second, are going to go in the first circle. So this is my A circle, and the second one is my B circle, and so that's where the third number goes. Okay, so those numbers always go in those places. So if you have the two-way table, you can transfer the numbers over. If you have the Venn diagram, we can transfer the numbers over. And then the last thing we're going to use is that general addition rule. Okay, so A or B. Probability of A plus probability of B minus the probability of both. And I think I'm just going to write it that way. Okay, of both. back in the dark ages when I was in school and we wrote on stone tablets, okay, instead of electronic ones, there was this whole topic that we covered in Algebra 2 and Algebra 1 that was called set theory. I really don't know why, other than just to understand mathematical notation, but I just want to show it to you because they use it a lot in probability, okay? That little U stands for union, and it means or, okay? So if you ever see that symbol, okay, looks like a U, it stands for union, which means or, okay? And then when we would do both, it would look like this, A, and it looks like an N, or an upside down U and B, okay? That was referred to as N, meaning intersection. And it stood for and, okay? Now, depending on who you had for Algebra 2, you might have seen some of those symbols, okay? But most people don't remember it, okay? It's not really tested. I mean, they say it's tested on the EOC, but I've never seen it. So, you know, they say a lot of things, but, okay? And again, you're going to always see me write it like it looks in black, okay? But I just would hate for it to, if you see that crazy notation when it pops up in one of your problems, all right? Just so you know, okay? All right, so let's do some practice on this, all right? Getting used to the notation and picking out all the things that it's asking me for, okay? As always, with all of your problems, there's lots of words, okay? They just always have done that, all right, because it's statistics. But let's take a look. They're talking about people who own homes. And it says, what's the relationship between educational achievement and home ownership? So a random sample of 500 U.S. adults was selected. Each member of the sample was identified as a high school graduate or not, and as a homeowner or not. And then they displayed it in this table for me, okay? So let's just think for a second. One thing that they did not put on here was a total. It's not required that you do that, but it just helps me to know that I got my data right. So I'm going to do that, all right? I'm going to do a total because I'm going to need that box anyway, okay? Now, if I'm paying attention to the words, I should know the total before I start because how many people were in my survey? $500, okay? There were 500. So let's check and see if they were right. If I add 221 and 89, that would give me 10, camera 1, 11, camera 1, 310. Okay. And then if I add 119 and 71, that would be 10, camera 1, 7, 8, 9, 190. That is indeed 500. Okay, so they did tell me the truth. All right. I'm going to do it on the other side as well, just to be sure. 221 and 119. Thank goodness we have calculators. 0, carry my 1, 4, 340. Okay, 89 and 71. 10, carry my 1, 160. That too is 500. Okay, I don't know if I'll need those numbers, but I'm just going to go ahead and get them. Okay, so that I have them. All right, so let's jump in here and let's look at what we've got. Okay, so it says it defines G as someone who is a high school graduate. So G for graduates. I'm going to put G up there so I know that's what it's talking about. Okay, and then H is for a homeowner. So H goes with those that are on the side. Okay, so G is yes, I am a graduate. G with a C means no, I'm not a high school graduate. Okay, H means I'm a homeowner. H with a C means I'm not a homeowner. Okay, so that's what that notation is. So the first thing it asked me to see is to find the probability of the complement of G. In other words, I'm the probability that I am not a graduate. Okay, that's what that means. All right, probability that I am not a graduate. Okay, so let's look. Okay, how many people total were in the no, I am not a graduate? $190, okay, 190 out of 500. Okay, so it was 190 out of 500. If they had asked me to write that as a decimal, we would just divide. It would be 0.38. Okay? So remember, if they want you to go from that fraction to the decimal, then we just do that. Okay? All right, so then it says, explain why the probability of G or H can't be just the sum of the two. Okay? Why can it not be the sum of the two? So let's just kind of walk through that. Let's do the probability of a graduate first. Okay? So if I look at the yes on my graduates, that would be this first column, which would be 310 out of 500. And then the yes on my homeowners, well, that would be 340 out of 500. Okay? And if I added those together, that would be 650 out of 500. Okay? And we know we can't do that. Okay? Because the biggest number I can ever get on top is 500. All right? So when that happens, we have to say it's not mutually exclusive. Okay, it's not mutually exclusive. Well, how do we fix it? Okay, how do we fix it? We have to take out the probability that they're a yes to both. Okay, so how we fix it is to take out the both. So I had 650 over 500. How many were in the both box? 221 out of 500. Okay, and so 650, does that give me what, 429? Okay, 429 out of 500, and so that decimal would be 0.858. Okay, so if they're not mutually exclusive, we have to take out those things that are both. Okay. So question about that one. To me, that's the hardest one. Okay, if they want all the yeses for, you just do all the total on the yes. If they want all the yeses for the other, you do the total for that whole yes line. Okay. Well, now it wants me to make a Venn diagram from my table. All right. So we know when we make a Venn diagram, we're going to have the box that's everybody. We're going to have one circle where they cross, and then we're going to have an empty blank outside. Okay. The easiest numbers to put in are the both and the neither. Okay. Where do the both always go? In the middle. And my yes was 221, so I kind of wrote that too small. I'll put 221 right there. Okay. And then my neither goes outside the circle, and that was my no, which was 71. Okay. All that's left is for me to do the G and the H, okay? Those two numbers that were remaining, right? The G and the H, okay? So I'm looking for the yes to just being a graduate, which would be 89. And then I'm looking for the yes to being a homeowner, but not a graduate. So that was that 119. Okay, so we put those four numbers that were in our box back in that Venn diagram. Okay. Whew. All right. One last one. Let's look at this one real quick. So it says define the probability that your person is not a high school graduate. So not a high school graduate, but is a homeowner. Okay. So another way to look about that would be the probability of GC. All right. So not G and H. Okay. So this, I think, is a little bit easier. We can see this from the table. You can see it in the Venn diagram, either place. Okay. So I kind of like the table. So they are no to a graduate, but yes to a homeowner, which is the only number in that chart that does both. That does that. Yeah, this one right here, 119. Okay. So it would be 119 out of our 500, which would give me 0.238. okay? Because it's and, that's an easy one, okay? Or is where we have to think about, do they share things? Is it more than the total number, okay? So if it's just and, we pick the right spot in the box, okay? So it's our 119. All right, so I want to look at a couple of different examples, all right, for us to look at, just to make sure that we get it, okay? So I want to look at some data that was collected by somebody else, okay? So not necessarily us, okay? So there it is. My husband can do the evil eyebrow. Drives me crazy. I can wiggle my ears, though. Wait a minute, I think I do this one. Okay, anyway. All right. I don't think that's a genetic trait. I think that's just a weird thing I can do. All right. So here we got all these things, okay? Students in a college stats class, they want to find out how common it is for young adults to be able to roll their tongues, raise an eyebrow, blah, 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 for all 200 people in the class, okay? Look, they put the totals on there. I'm so happy, okay? There's my total of 200, so yay, I didn't have to do that math, okay? It tells me that define event A is the person who can do the tongue, so A is the taco tongue, and B is the evil eyebrow. So I'm just going to label it, okay, so I know what they're talking about, right? So we want to find the probability of B, okay? So the probability that they can do the evil eyebrow, that they're a yes on the evil eyebrow. How many total yeses do we have for the evil eyebrow? 62. Okay, it is 62. Good. 62 out of 200. And I don't know what decimal that is. Let's see, 0.31. Okay. All right, here we go. The next one. All right, good luck. We want the probability that they can taco tongue and evil eyebrow. Okay, so and, that means I got to be able to do both. All right, so a yes and a yes. How many people are yes and yes? Just 42. Good. All right, so 42 out of 200, which is 0.21. Okay. Now, C, we want the probability of A or B. So or is where we have to think about, do I need to take some people out? Okay. So let's start with probability of a yes for event A. So a yes for event A, that would be that 149 out of 200. We did the yes for B, which was 62 out of 200. Do a quick add. Okay, 149 plus 62, is that more than 200? That's how I check it, to know if I need to subtract something out. Just add the top. 149 plus 62. Yeah, it's more than 200, okay? So we got to subtract out something. So we're going to subtract out the both, which was 42, okay? Which would leave me with 169 over 200, and that works, which would be 0.845. Okay, so just reading your table. Right. All right, let's do the next example, because it's all words. They don't give me a chart. They give me just a bunch of numbers and a paragraph. Ugh. Okay, and we have to pick out the good stuff. So take a second and jot that down so you have it. Okay. Yes. All right. Okay, so let's look at this one. Oh my gosh. So a 2018 survey suggests that 51% of U.S. teenagers use Facebook. So 51% use Facebook. 72% use Instagram. and 38% are both. Okay, so this is a yes to Facebook, a yes to Instagram, and a both. Okay, so I got a yes, yes, and a both. All right. What is the probability that the student uses Facebook or Instagram? In other words, I'm talking about the probability of Facebook or Instagram. Bless you. Okay, which means we're going to add some probabilities, but if it turns out to be more than one, then I'm in trouble. Okay, I'm in trouble. So let's look. Okay, I don't really like to deal with percentages, and so how can I make that a decimal? What would I need to do? Divide by 100. Okay, so I'm going to take 51 and I'm going to divide it by 100. It would give me 0.51. All right, same with 72, 0.72. Same with 0.38, or 38 would be 0.38. Okay, so we're going to start with the probability first of Facebook, which they gave me was that 0.51, plus the probability of Instagram, which was 0.72. Right? If I add those two things together, is it more than one? 0.51. Yeah, it is. Okay? So we're going to have to subtract out the probability of both, which was that last percentage they gave me. Okay? So a lot of times they will give me a probability as a percent, and they'll give me the pieces I need to be able to do what they're asking me for. Okay? So 0.51 plus 0.72 minus 0.38. I think you get 0.85. Right? So that's that general addition rule when things are not mutually exclusive, okay, when they share things. All righty. And I want to do this last one where they give me a bunch of data and I got to draw a Venn diagram, okay, because there's one like that where you have to drag the numbers in the right spot, okay? All right, rock and roll. So in a large apartment complex, 40% of the residents read USA Today, 25% read the New York Times, and 5% read both. Okay? So we select a random apartment, and we record what they read. All right? The first thing he wants me to do is to make a Venn diagram displaying all the things. Event A is they read the USA Today, and event B, they read the New York Times. So let's think about this for just a second. If we're going to make a Venn diagram, I'm going to need my two circles that overlap and then my extra out here. I'm going to call one A and I'm going to call one B. Okay. Now, the good thing is they gave me one of my numbers straight up that goes in it. Okay. We know in that middle circle is the both. Okay. The people that read both. And so what would 5% be as a decimal? 0.05. So in the middle, I'm going to have 0.05. Okay. Now, the tricky part to this is what goes in these outside circles, okay? Because that 0.05 is part of the total number. So if we look at the people who read the USA Today, 40% do, but I've already accounted for 5% of them. So what's 40 minus 5? 35. So in this A circle, I'm going to have 0.35, okay, because I had to subtract out what was both. Okay, so subtract out the both. We're going to do the same thing with the USA Today. They tell me 25% read, the New York Times, 25% read it, okay? So if I have 25 and I take 5 out, what's left? 20, so 0.20, all right? Now, how the devil are we going to figure out that last piece? All right, well, it should add up to 1. All of the probabilities should add up to 1. If I'm missing 1, let's add up what we've got. We've got 0.35 plus 0.05 plus 0.2. So that gives me 10, carry my 1. That gives me 0.60. And then to get that last little blank, I'm going to do 1 minus 0.60. And that's what goes right there. And so that would be my 0.40. Okay. So you'll have to do a little bit of arithmetic. If you know 3 of them, subtract it from 1 to get the one that you're missing. Okay? All right, then it says find the probability that the person reads exactly one of the two papers, so they don't read both. Okay, so they don't read both. They read just the USA Today or just the New York Times. Okay, and so if we're going to look at that, if they read just the USA Today, it would be 0.35. If they read just the New York Times, that's 0.2. If I add it together, it's 0.55. I don't have to do anything special to that one because they don't share anything. Okay, so the ones that just do it on their own. Okay. Alrighty, so let me get you started on this assignment. It is open. You can go ahead and get started on it. I think there are 5 questions for you to do. Okay, using your Venn diagrams, using two-way tables, and getting those probabilities. You're probably going to have to do some reading to see if they want it as a decimal, that kind of thing, and how many decimal places they want. All right.